Hello and welcome back. Today I'll be going over the basics of quadratic equations. Many of you are familiar with the standard linear equation, y is equal to mx plus b, giving you a graph that looks something like this. However, these types of equations only go in a straight line, and today we're going to be exploring beyond that. Here is a parabola. It's simply a curved line on a graph, and we have to find an equation for this line. Clearly, we cannot represent this with the slope-intercept form we previously discussed, which is where the quadratic equations come in. Quadratic equations are used to find the formula for a curved graph, and the three equations are as follows. Y is equal to ax squared plus bx plus c, y is equal to ax minus h squared plus k, and y is equal to x minus a multiplied by x minus b. The first equation is the standard form, which is used to show the parabola itself. The vertex form, the second formula discussed, is used to find the vertex of a parabola, and the factored form is used to find the x-intercepts of a parabola, or where the graph intercepts the x-axis. All of this may seem very confusing, so let's break it up. We'll start with the vertex form, which is y is equal to a multiplied by x minus h squared plus k. Let's look back at the graph we talked about earlier. To use this formula, we have to understand what a vertex is. A vertex is the lowest or highest point on a parabola. Our parabola over here has a curved bottom facing downwards on the graph. We can see here that our two lines seem to be parting away from each other and away from the bottom, and they don't ever seem to intersect. This type of parabola opens upwards, and the vertex would be at the lowest point. A parabola that opens downwards would look like this, with the vertex being at the highest point. Now, back to using the formula. We can see here that our vertex is located at -3, -1. The x-coordinate of the ordered pair represents the h over here, and the y-coordinate represents the k over here. We can plug in these numbers, and we get y is equal to a multiplied by x minus -3 whole squared minus 1, which is y is equal to a multiplied by x plus 3 squared minus 1. Now we can see that our graph intersects the horizontal axis, or the x-axis, twice, at -4 and at -2. We need these coordinates to substitute into the x and y part of our equation to find our a value, so we can substitute one of our x-intercepts, such as -4 and 0, into our equation to solve for a. After substituting, we have 0 is equal to a multiplied by -4 plus 3 squared minus 1, which is 0 is equal to a multiplied by -1 squared minus 1, which is 0 is equal to a minus 1. Adding 1 to the other side gives us a is equal to 1. Our equation is now y is equal to x plus 3 squared minus 1. You will now be learning how to expand a factored quadratic equation. When we look at our equation now, we have x plus 3 squared minus 1 is equal to y. The part that we want to be looking at is the x plus 3 squared, as it is enclosed within the brackets, and we have to expand this. One mistake several students make is simply squaring each number within the bracket, and they end up with an answer like x squared plus 9, which is extremely wrong. You have to multiply x plus 3 by x plus 3, which is the same as multiplying x by x plus 3, and then adding that onto 3 by x plus 3. Doing this gives us x squared plus 3x and 3x plus 9. And when we add them together, we get x squared plus 6x plus 9. Adding this back into the equation gives us y is equal to x squared plus 6x plus 9 minus 1, which simplifies into x squared plus 6x plus 8 is equal to y, which is our final equation. If you haven't noticed, we just used all of the quadratic equation forms when solving this problem. That may have been very confusing, so let's try out a second problem. We're given a graph like this, and we have to find the equation of the graph. Something to note is that our graph here opens upwards. First, let's look at the coordinates of our vertex. We can see that it is at -4, 0, so we can plug these coordinates into the equation of y is equal to a multiplied by x minus h squared plus k, which gives us y is equal to a multiplied by x plus 4 squared. Now we need to plug in one of our x-intercepts to see what our value would be, and luckily for us, we have one x-intercept, which is -4 and 0, which is the same as our vertex. We plug the 0 into y, and the -4 into x, giving us 0 is equal to a multiplied by -4 plus 4 squared, which is just 0a is equal to 0. Since we can get an infinite amount of answers, our a value would just be non-existent. Our equation becomes y is equal to x plus 4 squared. Now, Let's do what we did before and expand this equation. X plus 4 multiplied by x plus x plus 4 multiplied by 4. Doing this gives us y is equal to x squared plus 8x plus 16, which is our final answer. That was pretty easy, so let's try out a different problem. We're asked to find the equation of this graph, but we're faced with a situation different from our past problems. We have no x-intercept. Let's see what we can do. Let's first input the information we already have, which would be including our vertex, which is negative 3, 4. Plugging this information into the equation gives us y is equal to a multiplied by x plus 3 squared plus 4. Now comes the big problem. In the previous two problems we discussed, we used the x-intercepts available to us. But here we don't have that choice. However, we do have our y-intercept present, as a parabola will always have either an x or y-intercept, and there will never be a situation where a parabola never has either. Knowing this, we can look at the coordinates of our y-intercept, which is 0, 13. Plugging this into our current equation gives us 13 is equal to a multiplied by 0 plus 3 squared plus 4, which is 13 is equal to 9a plus 4. Subtract 4 from both sides to get 9a is equal to 9, meaning that our a value is 1. Our main equation can then be finally simplified into y is equal to x plus 3 squared plus 4. Using the tools that we had previously discussed before, we can do y is equal to x squared plus 6x plus 9 plus 4, which finally simplifies into y is equal to x squared plus 6x plus 13, which is our final equation. Congratulations! You've mastered finding the equation of a parabola. This is part 1 of the introduction to quadratics, and in further videos I'll go over factoring a quadratic equation and more. If you have any questions or topics you'd like to have covered, please let me know in the comments below.